Good day, how are you? My name is Blessing. So today we're going to talk about transformers. So what I'm going to do here, I'm just going to give some basics of a transformer. As you already given the definition from the document that you sent me, so I'm going to give a short definition, so that you get a more understanding of this transformer. The use of a transformer is to step. It's either it can step up or can step down the voltage in AC. Yeah, but if you check your document here, it's specific that transformers, they only work in alternating because there's a change in direction. You know, the definition from alternating is to change direction. So if you check the use of a transformer, there's a change in direction. It's either step up or a step down in the voltage. So what is going to happen is that the transformers, it's either they can step up the voltage or they can step down the voltage. So it depends on where it is used or where it is applied. So this is the basics, just a short definition of a transformer. So from here, I'm just going to explain in terms of a diagram. Let's say here given, this one is your primary, this one is your primary coil, and here are given your secondary coil this side. Let's say your secondary is having many number of turns. I'm just giving an example. Yeah, this one just a scenario. So let's say here you're given the number of turns at your secondary. Let's say NS. Let's say it's 1000. Now here, let's say you're given NP. This one is the number of turns at your primary. Let's say you're given it's 100. It's just an example. Just take your left hand side transformer as your primary, then take your secondary transformer, which is at your right hand side. So this one here, it's your secondary transformer, or I can say secondary coil, and this one is your primary. This one is your primary coil this side, which is the left hand side. So what is going to happen here? If you check this transformer, what is happening? We are having more number of turns at left hand side. Sorry, I mean we are having less number of turns at our primary side, and we are having more number of turns at our secondary side, which means our secondary coil. So what is going to happen here? This one is a step up transformer. This is step up because we are having the number of turns is increasing from primary up to secondary. So in the other way here, if the number of turns increases, what you need to know is that the voltage will also increase. So let's say you're given your VP here. This one is your primary voltage. Let's say you're given is 12 volts. You must know how to calculate the secondary voltage. I can write it as a question mark here. There's a formula that we are going to use here to calculate the secondary voltage. If you are given the primary voltage as 12 volts, so you are given your VP as 12 volts, then you are given your NP, which is primary number of turns, it's 100. Then you are given number of turns, your secondary number of turns is 1000. Then we don't have what? Our VS. Your VS is what? It's your secondary voltage. So it's unknown. So we need to calculate that one. There's a formula that you need to know, that which is very important, that you can apply to calculate that. I hope the formula, you already know the formula, and I think it's already given on that document that you sent me. There is this formula which says NS over NP is equal to VS over VP. Yeah, this is the formula that we are going to use to calculate the secondary voltage. So if you apply this formula, if you check here, we are going to place the variables which is given. We are going to substitute the variables which is given. We are given NS. NS is 1000, and you are given NP. NP is what? It's 100. Then equal to, we don't have VS, so VS is unknown, over VP. VP you are given 12 volts. So if you use a calculator to calculate this, you are going to see that our VS here is going to be 120 volts. Because of my space here, I'm just going to write the answer here. This one is a formula. After we apply this formula, we're going to get our VS as what? As 120. Yeah, so VS, the secondary voltage, is going to be 120 volts. So I'm just going to discuss what is happening. If you check here on this diagram, what is happening? The voltage is increasing. Why the voltage is increasing from primary up to secondary? Is because the number of turns increased. So that's the thing that you need to understand. If the number of turns increases from primary up to secondary, the voltage will increase. I think here it's very clear. Now, if you check here, yeah, let's say here, okay. Let me try to wrap the board. Yeah, let's say we already calculated. Our VS. We say here our NS it's 1000. So here our NP it was 100. Then we were given our VP, which was 12 volts. We calculate our VS as 120. The formula that we applied. So the voltage increases here. So what you need to understand also is that if the voltage increases, they say the current, let's say the current given here, I'm giving an example. Let's say primary current here, it's equal to 10 amps. You know, current is measured in what? In amps. If the number of turns increases from primary up to secondary, the current will decrease. I hope you know but they can ask you to calculate the secondary current here. What is the secondary current? Let's say the current is unknown. You don't know it. But you are given what? You are given the primary current. There's a formula that you need to know that will apply. NS over NP is equal to VS over VP. That V is voltage, so VS means secondary voltage, VP means primary voltage, is equal to current P over current okay, over current. Let me try to wrap here. My space is too small here. The formula is, it says NS over NP is equals to voltage S over VP is equals to current P over current S. Yeah, this is the formula. This formula is very important here. You must understand how to apply this formula. The formula, which is having number of turns, then it's also having the voltage, it's also having what? The current. So what you need to understand is that they say if the number of turns increases, the voltage will increase, but in other way, the current will decrease. If you check here, on our top term, we have NS, number of turns as secondary, then we're having voltage as secondary, our top term, but our top term here for current, it's primary, it's vice versa, it's inversely proportional. So in other way, you must know that if number of turns increases, the voltage will increase, but the current will decrease. This thing is very important. You need to understand this one. It's very, very important. If the number of turns increases, the voltage will increase, but the current will decrease, according from the formula which is given there. The formula is very important. So you need to understand the formula and you need to understand how to apply it. But this formula is already explained that if we increased the primary current, which means the current will only increase if the number of turns decreases. But as for voltage, if we increase the number of turns from primary up to secondary, the voltage will increase. What I'm trying to say here, let's say we are having lower number of turns at your primary and more number of turns at your secondary. They say if the number of turns increases, here the number of turns is increasing. If you check here, the number of turns increases, the voltage will increase from primary up to secondary. Let's say your voltage is 12 volts here. Then the voltage at Vs is going to be 120. I'm giving an example. The voltage is increasing. Why? The voltage is increasing because the number of turns is what is increasing. But the current will decrease. Let's say if here it's 10 amps, the current here, it must decrease. Let's say it can be 1 amp, for example. So this is what I'm trying to explain. If the number of turns increases, the voltage will increase, but the current will decreases. Then let's go to power. Power is very important. You know that the formula for power is equal to voltage times current from the variables given. So here we're having P, we can say we're having P in input power. Then we are also going to have what? Output power. We get output power from what? From the secondary coil. And this one is a primary coil. This is input power. So if we check from the formula, let's say if I want to calculate my input power, it's going to be voltage times current. So it's going to be what? 12 times 10. Yeah, we are going to multiply these two. 12 multiplied by what? By 10 amps. You get what? What are you going to get here? You get 120 amps. Then if you calculate your P out also, your P out is going to be what? Your secondary voltage multiplied by what? By secondary current. If you multiply these two here, you still get what? 120 watts. Units of power, it's watts, huh? Yeah, I think you know it. So if you check here, your input power is equal to what? To your output power. The power produced here remain constant. In other way, that thing that you must know it. When the transformer is working, the power transferred in the transformer remain constant. So in other way, input power will be equal to what? To output power. That's the thing which is very important. No energy is going to be lost here. Energy will remain constant, or they say energy will be conserved. Yeah, another way, the energy transferred per unit time will be conserved or will remain constant. So in other way, P in is equals to P out. This P in is power, input power will be equal to output power. So if you know the formula for power is equal to voltage times current, which is you're going to your voltage here is going to be primary times primary current is equals to secondary voltage times secondary current. If you check here, this is the formula that we also apply in transformers. if you check the formulas that I applied there, so in other way you can say Vp over Vs is equals to current S over current P. Yeah, which applies to the formula that I first show you at the beginning of the lesson. So that's it. So you need to know how to apply these formulas, and it will depend what are you given from the question. Okay, thank you. So if you're having any question, you can send it me on WhatsApp, or if you're having a challenge, if I can try to give you some exercise on these transformers, like how to apply these formulas, how to calculate the question that you can be asked in any exercise. Okay, thank you.